Okay, these are some more problems from the Chapter 3 review, and on number 31 and 33, we just want to find out where the function is differentiable, where we can take the derivative. So it has to be defined in its domain, and no zeros in the denominator of the derivative is one way to look at it. So we have to be careful. We don't have a piecewise function, so I don't think we need to worry about any corners or anything like that occurring. So if we take a look at this, first of all, we've got the natural log of x squared. Well, we know that this has got to be greater than 0. Well, x squared is always positive, so we just have to worry about it when it's 0. All right? And if we take the derivative, we can double check it. So if we take the derivative, that's going to be 1 over x squared times the derivative of x squared, which is 2x. One of these x's cancels one of those. We end up with 2 over x. And again, we can't have 0 in the denominator, so that's where our problem is. So it's differentiable for all x not equal to 0. All right? Or from negative infinity to 0, union 0 to infinity. Okay, number 33. Again, we can take a look at this. We don't need to worry about the bottom. This is always going to be positive because that's x squared, so that takes care of that. So just have to worry about when this is negative, not necessarily 0 at this stage of the game. So again, this is always going to be greater than or equal to 1. So we don't have to worry about that. So the sign is going to be determined by the top. So we just have to make sure that a 1 minus x is greater than or equal to 0, or 1 is greater than or equal to x, or x is less than or equal to 1. But we need to take a look at the derivative also, because we may have a little bit more here than we can tolerate. So let's take a look at the derivative. So we'll take the derivative of this implicitly. So we're going to use the square root rule. So we're going to have the derivative of the square root is 1 over 2 times the square root of that something times the derivative of the something. So we're going to take the derivative of this guy over here. Okay. And then we're going to have to use the quotient rule. So this gives us some good practice in the quotient rule. All right. So again, this is 1 over 2 times the square root of this rational expression. And then what we have over here is we have low d high. Low d high, the derivative of this is negative 1, less high, 1 minus x times the derivative of the bottom. The derivative of 1 is 0, 2x is, x squared is 2x. Okay, the denominator squared below, 1 plus x squared squared. Then I'll multiply this out, so I've got negative 1, negative x squared, negative 2x, and positive 2x squared. This is staying the same. Now what I'll do is I'll simplify the top here. 2x minus x squared is x squared, minus 2x minus 1, all over 1 plus x squared squared. And then over here, what we can do is we can bring this up. First of all, we can change it to a exponential equation, so it's 1 plus x squared to the 1/2, and then if I put it up so it's at the same level of this, I can make it to the negative 1/2. So we kind of rewrite this so we get rid of this complex fraction part. Okay? And another nice thing about this is we have 2 of these binomial factors that have the same, they're both the same binomial factors, so we can combine them. 2 minus 1/2 is 3/2, so we can put those together. So this is my final form. So this is my nice simplified form of the derivative. Okay. So I don't have any trouble with the top. And I don't have any trouble over here because this is always going to be positive because that's x squared. So I'm taking the square root of always a positive. So that's okay. So I just need to worry about this. Now, again, this has got to be greater than or equal to 0. But in this case, it can't even be equal to 0 because then we'd have 0 in the denominator. So we have to say that 1 minus x is greater than 0, not just greater than or equal to 0, which implies that 1 is greater than x or x is less than 1, so that's your domain. Or that's where it is differentiable. It's differentiable on the interval x is less than 1, or I could say negative infinity to 1. So it's differentiable. All right? So y is differentiable. The interval. Okay? All right, that was a little bit more involved than I thought it might be. But it's good practice of your implicit of your differentiation using the chain rule. Good chain rule application there.